Welcome back to The Explainer, brought to you by Forge College. Okay, so in our last session, we were completely obsessed with latency, right? We were making sure a single packet could move at absolute supersonic speed. Well, today, we're shifting gears. We're going to find out exactly how much data our turbine system can handle before it, well, completely bursts into flames under the pressure.
Here's our blueprint for today's stress test. We're going from latency to throughput, building our experiment matrix, setting up the harness, running the benchmarks, validating reproducibility, and finally, looking at your final artifact. Let's just dive right in.
All right, Section 1, from latency to throughput, shifting mindset. Before we even think about typing a single command, we really need to shift our perspective. We're moving away from measuring pure, isolated speed and looking at massive, sustained volume. Think about it like this. If our previous lesson on latency was like timing a single highly tuned race car on an empty track, throughput is a whole different beast. Throughput is figuring out exactly how many everyday cars we can cram onto a multi-lane highway all at once before we cause a massive, system-wide traffic jam.
Moving on to Section 2, the experiment matrix, systematic scaling.
So, to test this traffic capacity scientifically, without things just dissolving into pure unadulterated chaos, we need a precise blueprint. And that's our experiment matrix. We use this to systematically increase the load on our network. We literally open more lanes by increasing concurrency, jumping from 10 to 50 to 100 and all the way up to 200 concurrent requests. And we make the cars bigger, upping the payload size from 256 to 4096 bytes. We'll keep the run duration locked at 60 seconds and do 2 to 3 repetitions to see exactly when the node starts sweating and the servers basically consider rage quitting.
Which brings us to Section 3, setting up the harness, orchestrating runs.
Okay, we have our matrix, but how do we actually orchestrate all these different configurations without manually typing terminal commands until our fingers fall off? Well, we use a benchmark harness. Think of this as your automated, extremely rigorous lab assistant. In our case, it's an orchestration wrapper script, something like run_matrix.py. It automatically launches the test target, configures the specific parameters, captures all the system metrics, and perfectly tags the JSON output results. It keeps our environment strictly deterministic, which is great because it takes human error entirely out of the testing pipeline.
Setting up this automated assistant is basically a 3-step process. First, we start a local test validator to isolate our environment because, let's be real, accidentally DDoSing a shared production cluster is a quick way to ruin everyone's day. Second, we verify the measurement script with a quick 10-second sanity check. And third, we fire up resource monitoring tools, like VMstat, to capture CPU and network usage quietly in the background.
All right, Section 4, running the benchmarks, turning on the fire hose.
With our test environment perfectly prepped and our harness ready to go, it's finally time to turn on the fire hose. But wait! As you work through the matrix, you absolutely must remember the golden rule of the laboratory: isolate your variables. You should only ever change one parameter at a time. I mean, if you increase concurrency and payload size in the exact same run and the system crashes, you have zero clue which one caused the failure. Isolating variables ensures your data actually tells a clear, undeniable story. Here's the exact lifecycle you're going to follow. For every single cell in our matrix, we run the test for 60 seconds. Then, we bucket the timestamps to compute the per-second throughput. Immediately after, and guys, this is absolutely crucial, we repeat the exact same cell under identical conditions before finally aggregating everything into a CSV. Look, I know it's incredibly tempting to skip that immediate repetition step just to save time. Don't do it. Repetition is what proves your data isn't just a fluke.
Section 5, validating reproducibility. Solid evidence or noise?
Now that we've gathered all this slightly chaotic data, we need an irrefutable paper trail to check if it's reliable evidence or just random noise. For every single run, you need to look in your folders and verify you have these 3 specific files. The raw.json gives you the raw timestamps and success statuses. The vmstat.csv proves what the system's CPU and memory were doing. And the metadata.json records the exact flags and clock times. Honestly, without these 3 files, scientifically speaking, your experiment basically never happened.
What we are ultimately looking for here is reproducibility. This simply means that 2 entirely independent runs of the exact same matrix cell yield mean, steady-state throughputs that are almost identical. If you plot your 2 60-second test repetitions on a graph, the plateau curves should neatly overlap with one another. So you really have to ask yourself, did your throughput curves overlap within a 10% variance?
If those curves differ by more than 10%, something went wrong. You probably have rogue background processes stealing CPU power, or maybe even a silent node crash. If that happens, hey, don't panic. Just clear the lab, reset your environment, and rerun that specific cell until the curves overlap.
Finally, Section 6. Your final artifact: packaging the evidence.
Once your data curves beautifully overlap and you've conquered every single cell of the matrix, it's time to bag up the evidence. You're going to compile all your raw JSON files, your aggregated CSVs, and your metadata into a single zip file called transaction_demo.zip. Now, this neatly packaged file isn't just busy work. It serves as the absolute foundation for your upcoming capstone project. It's the definitive proof of your network's capabilities.
Remember, good experimental hygiene now saves massive amounts of analysis time later. Putting in the rigorous work today to ensure clean, documented, and reproducible data is going to make defending your capstone claims incredibly easy down the line. The data will simply speak for itself.
So, the ultimate question is, are you ready to find your network's absolute breaking point, or are you just hoping it holds together on mainnet by pure luck? Now it's your turn to hit the terminal, set up your harness, and execute these benchmarks. To master other advanced Web3 protocol concepts, be sure to visit forge.college to keep learning. Good luck with the Matrix, and I'll catch you in the next explainer.